Let us look at some questions from January 2016 Geometry Regions. Alright, let's get started here. So the first question is talking about the cross section of the right circular cone here below. Now, which of the drawing is not or cannot be a cross section? Then let's look at it. So first, can it ever be a square? In fact, this becomes our answer. No matter how you cut it, whether you cut it this way, or from top to bottom, however we cut it, we're not going to be able to get the square. Then how about on the other cases? How can we get triangle? You can get the in fact triangle by going to the tip over here, for example, and then cut it vertically from top to bottom. Then we would have gotten a triangle that looks somewhat similar to this way. How about this one? That is in fact, if you have to, it looks like a parabola, right? If you have to cut the cone parallel to one of the slant height, then the shape that which we would have gotten would have been looking something like this, number 3. Number 4 is a bit easier for us to guess, which is ellipse. Ellipse can be, if I were to just cut it right over here horizontally, parallel to the base, then it would have been circle, but if I do it slanted way, then it would have been an ellipse. So therefore, the last one is possible as well. Therefore, our answer is choice 1. Alright, let's look at the next question. An equation of a line perpendicular. When they say perpendicular, we're looking at negative reciprocal of the slopes. Now, to the line that's given by this way. So that means since the slope here is equal to negative 1/2, what is the negative of negative? Then it will be positive. Reciprocal of 1/2 becomes 2. So we realize that this 2 has to be the slope of the line. So we get y equals 2x plus b. But it has to pass through this point. That means I can plug that point in here and to figure out the value of b. So it says negative 4 is equal to 2 times 6 plus b. Now then here I get negative 4, which is equal to 12 plus b. And when I subtract 12 from both sides, b will be equal to negative 16. So therefore, choice 4 becomes our correct answer. Alright, let's move on to number 3 here. In parallelogram, that's shown here in this picture, diagonal TR is drawn, and then U and V happen to be just point on those two sides that we can see. Now, if measure of angle S is 60, this is 60 over here, and then SRT, this one is 83. And then TWU, this angle is equal to 35. Now, then the question is, what is the angle WVQ? WVQ. That's the angle that which we are looking at. Now, so then, among many ways which we can see, this angle is in fact equal to this angle over here. How? By alternate interior angles. Now, knowing that this angle is 35, then we can figure out this measure of the angle right here because they are supplementary. Then that becomes 145. So then what we end up getting is if I call this angle as x, that which we are looking at, then x plus 145 plus 60 plus 83 becomes 360. Why is that? Because 360 is the sum of interior angles of a quadrilateral. So you can see the quadrilateral in this way, in this manner, something like this. The yellow one. Alright, now, then all I have to just to calculate, so this becomes 205, and then up to here, 288. So x plus 288 equals 360. So when I subtract 288 from each side, then in this case we get 72. So x equals 72. Choice 3 becomes the answer. Alright, let's move on to the next question. Number 4. A fish tank in the shape of the rectangular prism has a dimension of this one, this one, this one that's given. Tank contains this cubic inches of water. What percent of the fish tank is empty? I guess we're looking at it in terms of the volume. So then if I have to multiply all three, I can say 14 times 16 times 10. Then here I'll be getting 2240. Now, but what we have at this point is 1680. So we just want to calculate the percentages. So 1680 divided by 2240. So 75%. That's essentially what we end up getting. But the question is, what percent of the fish is empty? That means 25% is empty. We just have to make sure to read the question carefully till the end. All right, let's look at number 5. We're looking for the transformation resulting in the perimeter of the triangle being different. Perimeter has to be different, but the perimeter is essentially the unit of length, so length has to be different. How could it be possible? Only thing that in this case would be possible is choice 3, because that's the expression for dilation by factor of 4 centered at the origin. So in that case, since the picture got bigger, a perimeter wouldn't be the same anymore. Let's look at number 6. Here, which statement is always true? AB is congruent to BC. AB is congruent to DC. Why is that? They simply said that FE, which is this one, bisects AC. So we know that this portion is equal to this portion. And then B is the, B, and then GE, which means this line over here, bisects BD at C. So that means this, all three segments are equal to each other. Which statement is always true? AB is equal to DC. AB is equal to DC. Is that always true? Yes, it is. Let's look at number 2 then. Oh, it seems like we already got the answer. But let's look at the second one. FB and then EB, FB, which is this one, and then EB has to be the same. No, there's nothing mentioned about these two line segments. BD bisect GE. We have no idea if this diagonal shape line is ever being bisected, so therefore that's not it either. Right, AC bisects FE. AC bisects FE. Same reasoning as the early one, choice 3. So therefore this one is out. Our only correct answer is choice 1. Alright, so we have a regular pyramid, and then whose base size measures 6 inches all around. If the altitude of the pyramid is 12 inches, find the volume. Notice that they're all in inches and cubic inches. The volume here is equal to 1/3 whenever you have the pointy top right over here. Base area, which is 6 square, times the height. Height is in fact, they told us that it is equal to 12. So then, all we have to do is multiply 1/3 times 36 and times 12. 144 becomes the answer. Alright, let's move on to the next question. Number 8. So we have triangles, ABC and then DEF. Which sequence of transformation maps the triangle ABC? This is the original to the other triangle. Now, notice that A corresponds to D. So if I have to connect those 2 points together, A and D, and then B and E, okay, Okay, you can see that they're intersecting at one point over here. How about C and F? Same thing. They all happen to line up at this particular point because that is the center of the dilation by -1, or simply point reflection as well. Or in fact, another thing that can be possible is reflection about the x-axis and then y-axis. So that's also same thing as point reflection about the origin as well. All right, let's move on to the next question, number 9. Important concept is those two angles are complementary. And then when the angles are complementary, we know that sine and cosine will be equal to each other. So that becomes our answer, choice 4. All right, let's look at number 10. A line that passes through the points whose coordinates are this one and this one, and dilated by the factor of 3 and centered at the origin. Okay, all we have to do is then 2 points, and then this becomes now 3, 3, and this point becomes 15, 21. But one thing that which we have to realize is when the line segment has been dilated, we realize that they're parallel to original line. The slope doesn't change. That's essentially what we're talking about. Let's look at number 11 here. So we have quadrilateral here given. When ABCD is rotated 90 degrees counterclockwise, so then A will go somewhere here, D will be going here, and then C is here, and then B is this way. And then they want us to find the image. All right, let's look at the when you're rotating 90 degrees, what's going to be happening? This used to be -2, 1, 2, 3, 4, 5, 6. So -2, 6 was my point, but as it moves 90 degrees, then it's going to be, and then it'll be right over here. I mean, actually, the point has to go down 6 and then -2 right over here. This point will travel to this far. Now, and then so if I were to look at the choices here, is distance preserved? The answer is yes. But when you try to get the 90 degrees, what do? You switch the x and y value, and then whatever used to be y, now it becomes x with negative sign. So then, what are some other points here? We have A was in 6, 6, 2, so that's out. Yes, B prime is -3, 4. So right now, B is 4, 3. So when you rotate it, it becomes -3 and then 4. So fourth one seems to be correct answer. All right, let's move on to number 12. In the diagram below, circle O, the area of the shaded sector is 2 pi. If the length ln is 6, what is the measure of the angle n? So now here we get, since ln is equal to 6, that means the radius is equal to 3. Since the radius is equal to 3, we can find the area. Let me call this one as angle x. So x over 360 times pi r, which is equal to 3 squared. That has to be equal to 2 pi. Then of course pi cancels out, and then this becomes 9. So we get x over 40. When you cancel out the 9's together, then we get 2. So when we cross multiply them one more time, we get x equals 80. So 80 seems to be our answer for x. But what I'm looking for is n. So therefore, I just have to get the half of the one that I just found, which is equal to x. Then our final answer is choice 3. 40 degrees, half of that becomes our answer. All right, let's look at number 13. So here we have these two triangles are similar. then we have to make sure the correspondence is there. AB is equal to 6, and then AC is equal to 8 by SAS. And we have two sides that will be proportional, but because A is in the middle, that means we have to have the congruent angle. Angle A and angle D has to be congruent, which is choice these two. Now, how about DE? DE has to be corresponding to this one, where the ratio between 6 over DE and then 8 over DF has to be the same. So let's try to look at it. In this case, it will be 9 over 6. I'm just looking at the first one. DE versus AB. That must be same thing as 12 over 8. So now simply when we cross multiply them, we get 72, which is equal to 72 as well. So choice 1 seems to be our answer. Number 14. The diameter of a basketball is approximately 9.8 inches, and diameter of the tennis ball is approximately 2.5. The volume of the basketball is how many times greater than the volume of the tennis ball? So since we're looking at volume in comparison to the diameters, the ratio of the length is equal to, now then, we can see that 9.5 to 2.5. The ratio of the volume has to be in fact cube of that. So 9.8, not 8, 9.5 cube to 2.5 cube. So then we can see that 9.5 cube and then 2.5 cube. So then this gives us the ratios. So I know that the ratio of the smaller piece is a 15.625, while the volume of the big one would have been 857.375. That same ratio has to be kept. Volume, that means how many times is this greater than this one? So now I'm just going to use the calculator here. So we're going to do the big value divided by the smaller value. Then we get 54.872. So then that's about 55. That seems to be the closest answer to begin with as well. So that becomes our answer. Let's look at the next question. Number 15. The endpoints of the one side of the rectangular pentagons are given in this way. What is the perimeter? Since it's irregular, that means whatever we get from here has to be multiplied that by 5. So if I had to sketch it, -1, 4 would have been somewhere around here. And then 2, 3 is around here. Then you can, of course, use the distance formula, or you can just check the change of x and change of y. How about change of x? It started from -1, it ended up being 2, so we get 3 as the difference in x values. How about y values? 4 and then 3. Difference here is equal to, in fact, 1. So then we end up getting distance between those two becomes square root of 1 square plus 3 square, which is equal to square root of 10. But we have 5 sides because it's pentagon right over here. So we get 5 times of. So let us look at number 16 here. We know that AC is equal to 9 and AB is equal to 14. We like to look at this angle A, and then we realize that the 9 and 14 is in the ratio of cosine. So we can say cosine of angle A must be equal to 9 over 14. Now then, what is A? A must be equal to second cosine or arc cosine of 9 over 14 becomes our answer. So let's try to do that. I'm going to type in second cosine, 9 divided by 14. So 0.99. So basically 50 becomes our answer. So let us look at number 19 here. We like to look at the lawn ornament in form of a solid sphere. And then we have density here that's given. And if the sphere has a radius of 4 inches, what is the weight of the sphere? So we are looking at volume of the sphere, which is 4 over 3 pi r, which is equal to 4 cubed. But after that, we just have to multiply that by 0.075. So if you have to put that into calculator, we'll be getting 4 divided by 3 times pi times 4 to the third power times 0.075. And once we have done that, then the answer is closest to 20. What are the coordinates of the center? Center is, in this case, we have to complete the square. So we have x squared plus 6x and give ourselves some space, plus y squared minus 4y, and then equals 23. Then here first we have 1, 6. So we have to add 9 to both sides. 9, we got it by dividing 6, the middle number, by 2, and then square that. So here we get 1, 4, 4. So I have to add here 4 as well. Then we end up getting x plus 3 squared plus y minus 2 squared is equal to 36. Now that means the radius is 6, so we are looking at this one or this one. And then the center has been -3 here, and then +2 here. -3 and positive. The choice 4 becomes the answer. All right, let's move on to the next question. Number 18. The coordinate of the vertices, this is given. What type of triangle is this? So it's kind of difficult for me to say right away. So I'm going to sketch that. R is equal to -2 comma -3. And the next one is a comma 2. And then 4 comma 5. So in fact, if I connect those 3 dots, it looks like this one is a right angle. Just to make sure, we're going to find the slope change of y is 5 became 2 -3, which, and then 4 becomes 8, which is equal to 4. How about this point to that point? 5 minus -3, which is equal to 8. And then 6 minus -2 becomes, 4 minus -2 becomes a 6. So we get 4 over 3. And therefore this became our answer. And then as you can see, the slopes are negative reciprocal to each other. Therefore it must be a right triangle. The similarity between these two triangles is 1 to 2. That means BO, which is from the smaller triangle, and GR, which is out of bigger triangle. So this is a smaller than this one. That means 2 times of this one. Since the ratio is 2 to 1 in this way, that means 2 times of the smaller one must be equal to the big one. So we get 2 times x plus 3 is equal to 3x minus 1. Then we get to realize that 2x plus 6 is equal to 3x minus 1. And then I just subtract 2x from both sides. And adding 1 to both sides, we get x equals 7. And then find the length of GR. GR is right over here. So if I have to plug in 7, then we get 3 times 7 minus 1, which is equal to 20. And that becomes our answer. Choice D. Number 21, in the diagram, the chords are given, and FDE is tangent at point D. Sam decided to apply this theorem to diagram. Angle inscribed in a semicircle is are the right angles. So that means Diameter is here. Then angle that which we are looking at is this angle, or I guess that's the only angle that which we are looking at. Which angle Sam is referring to? BCD, I guess that's, or DCB, which is choice 3 becomes the answer. So number 22 here we get altitude is drawn from the hypotenuse to the hypotenuse here, and which length would not produce the altitude that makes 6 radical 2. So if this is 6 radical 2, and if I call this portion as A and if I call this portion as B, we get to realize the relationship is 6 square root of 2 square would have been equal to A times B. Now, that is equal to 72. So we are looking at two numbers that multiply to 72, then it'll be okay. Let's look at the first one. AD, which is this portion is 2, and then DB is equal to 36. So 2 times 36, is that equal to 72? That's okay. AD, which is equal to 3, and then AB, which is equal to 12. Wait a minute, if this one is equal to 2, and whole thing is 3 and then 24, then this portion is 21. So 3 times 21 is not in fact equal to 73. It is in fact 63, so therefore choice 2 becomes the answer. And the others will multiply to 72, including number 4 because it covers up to AB. Now let's look at number 23. A designer needs to create a perfectly circular necklace. So now here we have radius of 10 centimeters. That means what's the circumference? Circumference will be equal to 2 pi r, which is equal to 10. But has the 1000 centimeter wires. So basically what we're going to be doing is we're going to do 1000 divided by 20 pi when I calculate this one. So let's try to look at this one. So here 1000 actually. 1000 divided by parentheses 20 pi. Alright, so we get 15.9. That doesn't mean that actually we can make 16 because we don't have quite enough to make the 16 necklaces. So therefore our answer will be only 15. Alright, let's look at the next question, number 24. So here we have, notice that the angle C is congruent to angle OTU. So these two angles are congruent. So we have to look at the correspondence here. TU is equal to 4, and then OU is corresponding to 5, and then OC is equal to 7, and then find the length of ST, which is equal to, I'm going to call that as X. Then we have to see that 4 is correspond to 12, so 4 over 12. That's how I can set it up. Because this side corresponds to not this one, but this way, by looking at the location of the congruent angles. And then, how about 5? 5 is the opposite from this angle. That means opposite from that angle would be x plus 4. So then all we have to do is simply multiply them together. We get 4x plus 16 must be equal to 60. So when I subtract 16, we get 44, which is equal to 4x. Therefore, x will be equal to 11. That gives us the choice 3 as our answer. Triangle ABC is graphed on the set of x's by reflection about y x equals 1. So the purple line could have been x equals 1. So then this B, since it's 1 unit away from the line, so it's going to go for 1 more unit over here. C goes over here as well, same thing. And A is 1, 2, 3, 4. So 4 the other way, 1, 2, 3, 4. and that becomes our basically answer. All right, let's look at number 26. In the diagram below, here circle O, and then angle BCD. BCD, this is equal to 30. Then that tells you that this arc BD is equal to 60. And then state the measure of the angle AOB. AOB. What's the measure of this angle? So I'm going to call that as X. We get to realize that since this is equal to 30, that makes this one equal to 30. But since this one is an isosceles triangle, since that's equal to 30, this one is equal to 30 as well. Then when you combine all three angles, that has to be equal to 180. So we get 180 minus 2 times of 30, which becomes 120. So 120 degrees becomes our answer, choice 26. So let us look at the direct line segment here. It says P is equal to negative 2 comma 1, so it's right over here. And T is equal to 4 comma 7, so 4, 7, 1. So that's the value. That's the points that we see. So I'm going to connect it here to here. That's what we have. Now, notice that the ratio between those two is 2 to 1 ratio. That means when I try to figure out the changes of x and changes of y, has to be in total of 3 portions. So I can say this can be 3a, but total length is 2, 4, 6. So 3a is equal to 6. That means a must be equal to 2. So each portion is 2 coming from P. That means 1 portion and 2 portions. So I'm right over here. When I go up, I know that I'll be meeting up with that point. Then, what is that point? 2 units to the right, and then 1, 2, 3, 4, 5. So we get 2 comma 5 is our point which we are looking at. 28. A prime, B prime, C prime is the image after sequence of transformation. One simple thing which I can see a little bit, it would have been this one has been reflected about the y-axis, and it becomes right over here. 3 units, 1, 2, 3, and then 4 is 4 units, and then 1 diagonal below. So we get all right. So once we move over there, we can bring it down to make our A prime, B prime, C prime. So now that means we're looking at reflection and then translation. Because triangle A prime, B prime, C prime is result by reflection about the y-axis, and then followed by translation of 0. We're not changing the x values, but y value is equal to negative 4. Then that's how we can say ABC. All right, let's continue. Number 29. A carpenter leans on extension ladder in this manner. Determine the state and then the length of the ladder. So what is the length of the ladder? So this becomes 30. Then I don't know what the length of the ladder is, so I'm going to call that as L. Then we get to actually realize that sine of 70 is equal to 30 over L. Now, so then I can swap those two things around. So we get L will be equal to 30 divided by sine of 70. So then here we get 30 divided by sine of 70. So we get 31.9, so we get almost 32 feet becomes our answer. Number 30. During an experiment, so we have this many bacteria when the diameter is 51 millimeters, 72 in this case. So then let's find the density. Density is the number divided by the area. So we get first one, density A is equal to 40,000 divided by area of this one, which is pi 2.5 square. So then here we get 4,000 divided by 2.5 squared, and then times by pi. Oh, actually, it's not 2.5. Sorry, it's a 25.5. I have to just modify this one just a little bit. Insert 25.5. Then we get 19.8. So, or 19.6. 19.6 bacteria per unit area. In this case, we're going to do the same thing. Density of B is equal to 72,000 divided by pi, and then 37.5 squared. So then here I'm going to put that into calculator. 72,000 and we are dividing that by pi, and then 37.5 square. We forgot the square over here. So we have 16.3. So therefore, Petri dish A has a higher density. Alright, let's move on to the next question. Number 31. Line L is mapped onto line M by dilation. When it's dilation, the slope doesn't change. So what is the slope here? Slope is equal to y is equal to 3x minus 4. So slope doesn't change. So we get y equals 3x plus b. That's what we have. But scale factor of 2, that means since the slope doesn't change, we end up getting this portion. But b, our original y-intercept used to be negative 4, but when you scale factor by 2, then it becomes negative 8. So we get y is equal to 3x minus 8. That becomes our final answer. Number 32. The aspect ratio is given in this way, and the length of the diagonal screen, diagonal of the screen is the screen size. To the nearest inch, the screen size. If this flat screen, height was 20.6. So height is 20.6, which corresponds to 8. So we get 16 over 9 must be equal to x over 20.6. So I can simply cross multiply them. So x becomes 16 times 20.6 divided by 9. 36.6. But they want you to do the nearest inch. So then it becomes, actually, I just found the other side, but I didn't find the screen side yet. So we have to go for one more step. Then our answer is, to get the screen side, we're just going to use the Pythagorean theorem. So here we get 20.6 squared plus this 36.6 2 squared must be equal to screen size. Let me call that as S squared. So we get 20.6 squared plus 36.6. And then, so if I were to get the value, I'll be getting this one. And 1763, we have to take the square root of that number and raise that by 0.5. Then 41. So almost it becomes 42. So 42 becomes our answer. All right, let's look at number 33. So we are trying, in this question, we're trying to show that the sum of the measures of the interior angles in a triangle is equal to 180. So what was the first step? In the triangle, we have drawn this line. So there's different ways of writing it, or we can just write down drawn. That's perfectly fine, because that's just drawn, added onto this one. And the second portion, it says angle 1 is equal to angle ACD. Angle 1 is equal to angle ACD. Why is that possible? And angle 3 must be corresponding angle, because that's alternate interior angles. So we get alternate interior angles are congruent in parallel lines. That's basically what we end up getting. And then we can say these three angles makes up a 180 because they are sum of the angles that form a line is 180 degrees. Now, lastly, when you add up 1, 2, 3, because those are the correct same location here earlier, so we can do the substitution. Because we had an equal amount that has been substituted to get to the last condition. All right, let's move on to the next question. Number 34. Construct this triangle. All right, so now then in this case, what I'm going to do is this. I'm just going to copy the each line segment. If I copy each line segment, then that's essentially SSS postulate here. So I'm going to start from here. I'm going to open this one up to see how wide it is. I'm going to do that over here. Now let's copy one side. So I'm gonna copy this line segment over here. And then lastly, it's almost right over here. Good. And then, so we realize that that's the common point. Then what we can do is with the ruler, all we have to do is just simply connect them. All right, so there it goes. The red one is the copy of this one. Since what we have done was we used the concept of the same line segment. So justification, postulate would have been SSS, because this side is equal to this one, this side is equal to this one, and then that would be the equal to corresponding side here. All right, let's look at number 35. Parallelogram is the bigger one, ANDR. Now, those two line segments are bisecting that in halves. Prove the triangle ANW. ANW, this triangle, is congruent to DRE. DRE, this. So how can we do that first? As you mentioned, the side AW and then ED are bisecting the opposite side, so this must be equal to this one. So as this one is equal to this one. Why? Because all opposite sides are equal to each other, so therefore halves of the opposite sides must be equal to each other as well. Now, then the next one is, we just mentioned that opposite sides are congruent, and then halves of them are congruent, so we realize that one. And this angle is congruent to this angle. Why? Because opposite angles are congruent in a parallelogram, and then the other pair of the opposite sides are equal to each other in the parallelogram. So we realize that those two triangles that which we are looking at end up being the congruent triangle by side angle side. And then lastly, prove that the quadrilateral AWDE, which means the one that's inside, is a parallelogram. How can we do that? Among many ways which we can do, since we show that these two sides are congruent already, but we realize that those are parallel as well. Why is that? Because when opposite sides are parallel, parts of the parallel sides must be parallel as well. Once again, when two lines are parallel, parts of the parallel sides must be parallel as well. Then we just prove that one pair of the opposite sides are congruent and parallel, so that's why it must be parallelogram. I'm just gonna skip the writing, and then you can just try to write it yourself one more time. All right, let's look at number 36. Here, Kathy wants to determine the height of the flagpole. So we see the picture over here. And then we want to see how long this one is. Since this one is equal to 8, this is type of question that we've been looking at many times here. The most important line segment will be one in the middle, because it is shared by both triangles. And notice that this angle is sum of this angle plus this unknown angle. So what I'm going to do is I'm going to do 52.8 minus 34.9. Okay, so that becomes 17.9 here. Then now we can use the law of sines to figure out the yellow side. I'm going to call that as x. Then we get x over sine of 34.9, which must be equal to 8 over sine of 17.9. So then all we have to do is, to get x by itself, I'm just going to multiply each side by sine of 34.9. Then here we get 8 times sine of 34.9, but divide by sine of 17.9. Alright, so we got to realize that that was equal to 14.892. Alright, now so we can use the, since I know the hypotenuse of the small triangle right over here, so then I can look at the upper portion. I'm going to call that as u maybe, using the sine. So here we get sine of 52.8 degrees is equal to u over 14.892. Then to have the upper portion, we just have to multiply this one times this one. So we get, multiply that by sine of 52.8. We get 11.86. Then this one is 11.86. Bottom one is 1.7. So I'm just gonna add that number to 1.7, which our final answer becomes 13.56. So then 13.6 meters would have been our final answer, because to the nearest 10th of a meter. Alright, so I think that is it. I hope you enjoyed it, and I'll see you later. Bye-bye.